turmoil of the collision explains the warped shape of the galaxy's disk, as seen in this wide view from a ground-based telescope. There is something else about Centaurus A that stands out. Using radio and X-ray telescopes, astronomers have spotted powerful jets blasting out of its center and broad plumes of matter racing far beyond the galaxy. Where is all that energy coming from? Answering that question has become a major focus of Hubble observations since the day it was launched. Astronomers had long noticed that the centers of large galaxies are unusually bright. They speculated that there must be some kind of massive object lurking there. Could these objects be dense collections of stars? Or are they a breed of supermassive black holes? Millions or even billions of times the mass of our Sun. Hubble's search for the answer began in the center of a giant nearby galaxy, M87. Astronomers saw that its color was not quite the same on both sides. One side was shifted towards blue, and the other towards red. A hint that it must be rotating very quickly. This is because the wavelength of light is changed by the motion of whatever is emitting it. This is also known as the Doppler effect. Think about how the pitch of a train whistle drops as it races past. Similarly, if something in space is moving towards you, the wavelength of its light gets squashed, making it appear bluer. If the object is moving away, its light gets stretched, making it redder. By measuring how much the colors had shifted from one side of the disk to the other, astronomers were able to determine its speed of rotation. It turned out that this disk was spinning at a rate of hundreds of kilometers per second. Astronomers concluded that an object must be lurking in its center that's at least 4 billion times the mass of our Sun, a supermassive black hole. This was a key piece of evidence in the discovery that supermassive black holes occupy the centers of most, if not all, large galaxies, including our own Milky Way. Back in the early 20th century, the young astronomer Edwin Hubble joined a larger quest to understand the scales of time and distance that define our universe. To make his measurements, he observed stars in the nearby Andromeda galaxy, just 2.4 million light-years away. His namesake, the Hubble Space Telescope, has extended those measurements to the far limits of time and space. In its legendary deep field images, Hubble stared into seemingly blank regions of sky, revealing thousands of faint galaxies from the early days of the universe. These blotchy collections of stars are infant galaxies. Over the 10 billion years their light has traveled to reach us, some may have evolved into galaxies that resemble our own. With a supermassive black hole in its center, spiral arms, exploding stars, solar systems, planets, and perhaps even life. Hubble has shown that our Milky Way galaxy is a dynamic cosmic laboratory. Some of its most striking and beautiful images are giant structures known as nebulae. This one is nicknamed Horsehead, after its clear and curiously familiar shape. Rising from a sea of gas and dust, this so-called dark nebula is a cold, dusty cloud set against a background of glowing gas. Then there's the famed Eagle Nebula, nicknamed the Pillars of Creation. A group of hot young stars is scouring these luminous towers with fierce winds of energetic particles. Dense pockets of gas resist these winds. Within them are cocoons of gas and dust, where new stars are being born. You can see the same process underway in the Monkey Head Nebula, about 6,400 light-years away in the constellation of Orion. The Monkey Head is a stellar nursery with all the ingredients needed for star formation. Its peaceful beauty masks the violent events within it. In places where stars are able to form at high rates, Hubble astronomers have zeroed in on the moment of birth. One team has been collecting high-resolution Hubble images of energetic jets of matter being shot from newborn stars. Unlike most astronomical phenomena, which can appear motionless over centuries of time, these jets visibly change on human timescales. Using Hubble, astronomers can see knots of gas brightening and dimming. This shows that these jets are not being launched in a steady stream. Rather, they are racing out sporadically in clumps. The irregular structure of these jets is likely caused by material that periodically falls onto an infant star. This image shows how violent the end stages of star formation can be. In the constellation of Cygnus, a few thousand light-years away, lies a compact star-forming region called S106. A young star named S106IR is being born at the heart of the nebula. In the final stages of its formation, the star is ejecting material at high speed, disrupting surrounding clouds of gas and dust. 3D visualizations show the extent to which the star has carved its surroundings into a complex shape, including hollow cavities. At the outer edges of these cavities, the gas has been compressed into shock fronts. The material spewing off the star not only gives the cloud its hourglass shape, it is heating it up to temperatures of 10,000 degrees Celsius. The star's radiation excites the gas, making it glow like a fluorescent light bulb. A star is born when pressure and heat in its core cause hydrogen gas to undergo nuclear fusion. The heat generated by this process pushes outward, countering the inward pull of gravity. From the violence of their birth, most stars spend their lives shining in relative peace, gradually using up the hydrogen fuel that makes up their cores. Smaller, cooler stars are incredibly efficient. A red dwarf with 10% the mass of our Sun can burn for 10 trillion years, almost 1,000 times the current age of the universe. By comparison, larger, hotter stars like our Sun burn more quickly. At about 5 billion years old, our own Sun has gone through half its expected lifespan. By observing stars similar to the Sun, scientists now have a good idea of what will happen to our solar system in the distant future. The Sun will grow steadily hotter, causing it to swell into a so-called red giant. When the Sun does this, it will destroy the inner planets of the solar system. Next, the outer layers will puff out, forming a dense cloud of gas and dust that will obscure the visible light from the star. In this stage, it forms a protoplanetary nebula. Only dim infrared emissions from the dust cloud and reflected starlight let astronomers see anything at all. Hubble images of this stage show a wide variety of shapes, hinting at the complex dynamics at work inside. The spiral structure of this nebula is particularly unusual and is likely due to a second orbiting star that is producing swirling patterns in the gas and dust. Over a period of a few thousand years, radiation from this hot remains of the star excites the gas in the nebula, causing it to glow. The once faint nebula now becomes a bright and mysterious cloud called a planetary nebula. This type of nebula populates our galaxy with luminous shapes that draw the gaze of many a skywatcher. Eventually, planetary nebulae fade to nothing as their gas and dust diffuse into space. All that remains is the tiny white dwarf, a form that our Sun will take billions of years from now. Planetary nebulae are more than just beautiful shapes that grace our galactic skies. They show important stages in the life cycle of stars and how they interact with and even shape their surroundings. Hubble has given astronomers the sharpest views yet of these ghostly, dynamic structures.